As promised, in this segment we will take up this problem and see how to think about it programmatically to come up with an algorithm, roughly an algorithm, an informal algorithm. Okay. Now, like the bucket thought process, suppose I have a bucket B1, again I'll call it say B1, then I have a bucket say B2. Okay. Now, and then as usual I'll put those start with 1 and 1 there, the way we did last time. And yeah, let's think about the next step. So our first point was, we should ask a question that whether we have reached the end. To start with, even have we reached already the end? Now what should be the question now? If so here you have to think that this one which you have put it here, in the previous example we were taking this to be the number which we were using. You remember? If I can go there, not this. See, we were picking this number, so 2 was coming, then 3 was coming, like that, and at the same point this was containing that number. Okay, but now here we even don't know what that 99th term will be. So how to decide when to stop? Because please, and then make sure that you pretend that you don't know how to calculate that 99th term is, because I know that you can calculate that, but please pretend that you can't calculate that 99th term. So you cannot put a condition to check whether should I stop or should I proceed. Okay, one more step. Now, so that is why, but number of steps are now quite fixed, because if we have to calculate 99th term, that means you have to do the summation like 98 or 98 steps you have to proceed, because the second number you have to add, so 1 step, third number, so 2 steps, so like that. So you know that now you have to take 98 steps. So it's always now it's very natural that this should be the steps, and okay, I'll call these are the steps and not these numbers which are being added, as opposed to the previous example. Okay, then okay, if we say if the answer is no, we should go to the next step. Let me put this one, and now I'll again draw the buckets. So this bucket is having 1, this is 1, and what should I do now? And then because this is the steps, so I'll definitely put say 1 plus 1 is equal to 2. So instead of here writing say 1, I'll write this number 2, that is I am at the second step, and so that I can compare this with 98, which is the total number of steps that I must take. Okay, but then the question is, this is fine, but then what should I put it here? 3, it's obvious, but how do I know that it's 3? Because this I had done last week, and this week I completely have forgotten what is to be done. I just know that this is my second week of addition, but then what should I add? This 3 is not at all known to me. Because I have to get that somewhere from here, okay, from the previous week's buckets position or size and those things. I have to calculate here. Okay, that means I should have a fixed statement, and that statement should be executed like earlier case we were there. This you add 1 and whatever number comes you add there. So that was a fixed statement which we were performing every time. But now what is that statement? If I add 2 to this, so will it work? So now suppose this is 1, whatever is there in that number, I'll add 2 to that and add that number here. So that means I'll bring this thing, I'll put a different color, So I'll bring that out, then I will add 2 to this. This 2 is now a fixed number, and whatever comes, that I will add here. So as plus 3. Okay. If I think I'll do that, then will it work? Let's see. Now it will become 4, but once I go to say the next step, suppose I have to go to the next step and it's not the end of my calculation, then I'll have to do 4 plus 2 and I will add 6 and I have to add 5. So that means this is not working. Okay, so that's how you should think, that whether the steps which you are planning to take, repetitive steps, are they working, or for at least some of the future steps. You should always check that. Now I'll just retrieve that. So that didn't work. So what else we can do? Okay, let me say another one. If I say that, okay, whatever is there in this number, I'll take that, I'll multiply that with 2 and add 1. So I'll get 3. Okay, so then that I will add. Okay, so plus 3. Now should it work in the next step? I have 2 here. I will bring 2, multiply by 2, then add 1, I'm getting 5, and yeah, that's working. Great, good. But then, and then 5 if I do, so here it will become 2 plus 1, 3. So 3 times 2, 6 plus 1, 7. So yeah, so that's working. But the issue is I'm pretending that I don't even know how to multiply. Okay. Suppose you know multiplication, then yeah, so this is definitely a way to know every week, these are weeks, right? Every week that what number to add just by looking at our previous or the previous week's status of the buckets, right? So that's our main thing. We can't remember anything from other than these buckets. Okay. Then, but suppose you pretend that you don't even know this multiplication. What can you do that, or you can't do that? You can do it. So for that, what you have to do is you have to say add one more bucket maybe here, where you are keeping a memory sort of thing of whatever is here. Okay, suppose 1 here, so you just copy this thing. Should I put a different color for copying? Yeah, maybe this. So you just copy this, means copy it here. So that means 1 will be here, and to this number you now just add 2. Okay, will it work? No, this will become exactly the same thing which we did here, right? 4 plus 2, it will become, no. So what you should do is, whatever you are adding here, so that should be, okay. So to start with, you keep the bucket, but don't put anything there, here. And okay, what you do is, once you calculate this, you add that number to this bucket. Okay, let's say that bucket was there with you, you didn't put anything there, and now as soon as you get this number, you take it there for addition, but you also keep it here. Okay, to start with, you could have started that with 1 again, because whatever you added there in a way should be put here. Okay, so in this case, whatever is added there, you are making a copy of that. So that I'll put as say this color. So copy this thing here. Okay, so this is not a copy, so I should erase that. So this is not a copy, this didn't work, we saw that. Okay, so this didn't work. So now this copy, if we do, and then our algorithm is whatever is there in this, take that and add 2 to that, and then just use this. Okay. And now will it work for the next step? Suppose we say we check it here whether it's finished. No, 98th step hasn't yet been reached. So again answer is no, so we will go there. So again let me, okay, sorry. So let me draw the buckets. So here there is a bucket, here there is a bucket, and one more bucket now we have. And from this no, we will say that okay, 2 plus 1 is equal to 3, so we will put 3 there. And what about here? Here it's already 1 plus 3, it has been calculated and kept there. And now we are saying that we will take this 3 and add 2 here. Okay, it will become 5. This 5 we will add, and this 5 also we will make a copy here. Here means we will not add to that, we will throw it away and keep that. Okay, so this is very important. So here I haven't added this 3 to here, I just removed this 1, I threw away 1 and kept 3 instead of that. Here I threw away 3 and put 5 there. Okay, so then this will now work for every step. If I go to next, obviously it will be with 1 plus 3 plus 5, and this will be 3. So now the answer is, the conditional thing is no, so you will add 3 plus 1, you will put 4 here, and then what? This 5 you will take here, 5 plus 2 equal to 7, this 7 you will add here, and at the same time you will throw away this 5 and keep this 7 here. Okay, so that's how you can just move on. But then what happens once you go to a stage where it's already 98? Okay, so then you compare that and you will say that yes, it is 98, and by that time whatever number would be here, we don't know because we didn't calculate that, and then that number will be brought in and added to 2 and put in there. But then it won't be done after you do the 98th step. So that is where I am saying there may be a possibility that while thinking like this, sometimes there could be issues with the ending and the starting things, which are little bit detailed thought process should go there. But please do not worry about such things at the beginning. If it works for all the intermediate steps, you are done in fact, and you just have to think a little bit once we go to the algorithm and coding stage. Once they don't match properly, you can always come back and fix these endpoints. If you are able to think properly about the endpoints, quite well and good, but don't worry much about the endpoints, whether they are working or not working. Should I stop at 98 or should I go to 99 or 97? So what will work for me? So that kind of things, sometimes they create a little bit issue, because there will be an issue of whether should I put 98 means comparison as more than 98 or more than and or equal to 98. So such kind of things will come up, but please don't worry about them now. So the broadly your repetitive steps should work to give you the complete answers. So that's how we should think of. We will stop for this segment here, and we will take up another problem to find out the greatest common factor GCF of two numbers by using Euclidean algorithm. We will see the bucket method for that in the next segment.